Hello, everyone. Welcome back to Let's Talk About Data Show. Back again with me, Lydia Ray, Senior Analytics Solution Architect at AWS. Last week, I was helping Tony chat moderating. Now I'm back on screen, back on the camera. Welcome, everybody. Uh, as you see, this topic this week. It's something that's closest to me, that I care about deeply, and I get lovely people here. I will let them introduce themselves first. Anyone want to jump in first? Candice, maybe you already off mute anyway.
Yeah. Hey, everybody. I'm Candice Bohannon, and I'm a specialist solutions architect working on Amazon Q Developer. I'm really excited to be here today to talk about this application and a little bit about She Builds and dive into the data and how we came up with this idea.
Thank you. Tara or Donato?
Happy to go. Hi, everyone. Really great to meet you. My name is Tara Kane. I'm Partner Solutions Architect here at AWS based in London. And myself, along with my colleague Naomi Teng, founded the AWS She Builds Mentorship Program. And so very excited today to talk about one of the tools that we've built for the program. Looking forward to the chat.
And last but not least, Donato.
Hi, everyone. So my name is Donato. I'm a senior prototyping architect with prototyping and cloud engineering. I'm based in sunny and warm Brazil, and I'm the father of 2-year-old Angelina, one of the reasons why I joined She Builds last year, as it debuted in Brazil as well. So happy to be here.
Thank you. I forgot to say I'm in the UK, so I'm in Tarno, UK, in the different city at the moment is as UK weather, cloudy and rainy. So jealous with Donato. But anyway, if you are new to the show, don't forget to first of all check out our community page. All our past show will be in there, so you can rewatch it again, including this show. So once we finish today, you can still watch it on demand. And please pop in the chat where you are, how are you, and then where you're tuning in, where you're watching in. We would like to know more, and then how's the weather there. Okay, so let's get to the topic, right? First, I want to, before we get into this GenAI, which is very exciting, but let's understand first about the mentorship itself, because this GenAI tool, as my understanding is, comes from the AWS She Builds mentorship program. So I think Tara, as your co-founders, would you tell us first, what is the AWS She Builds mentorship program?
Sure. Thanks, Lydia. So the AWS She Builds Mentorship Program is a free program that we run at AWS to really help those who identify as women either enter the technology field or to continue to progress their careers in technology. And so the way it works is that we match external mentees with mentors who are from AWS for a 12-week program. And throughout the program, the mentors assist their mentees with their goals. So those goals might be a whole range of different goals. We get mentees who are early in their career who are interested in learning about how to update their resume and how to practice for interviews, all the way through to C-suite execs who come through looking for support from AWS around leadership skills or perhaps team management or their communication skills.
Okay, that's really great. I mean, I've been helping in this program for the last 3 years, and it's really great to have this type of program. But as you are the co-founder, and then you see the programs grow, you see the challenge you have, what was triggering you, or the motivation that behind to thinking about okay, let's use GenAI for helping this mentorship program? And I'm sure GenAI was started 2-3 years ago, became a thing, and there's a lot of gaps around it that could be a challenge for applying this type of tool within this topic. So would you be able to share okay, why you started this GenAI tool, and also what challenge you're trying to address?
Yeah, sure, absolutely. So this year is our 5th year of growing the program, and we've been incredibly humbled over the last 5 years with just how many mentees who want to join the program, which has been super exciting. But as you can imagine, has also presented a challenge around the amount of time it takes us to evaluate all of the mentor and mentee applications and then actually match the mentees and mentors based on a range of criteria. And so as we've continued to grow and scale the program globally, this task of matching has really become, I'd say, a bottleneck for scaling the program, and really one of the key reasons that we haven't been able to grow perhaps as much as we had wanted to, because we really put a lot of time and care into that matching process, and really believe at the end of the day that match is the most important part of our program. Because at the end of the day, if the mentee and mentor are not a great match for each other and not a good fit in terms of their skills and goals and alignment, then the mentor won't be able to help the mentee to the best of their ability. So as I said, pretty much the challenge has been around the number and the sheer number, and being able to scale this program more effectively. And so one of the ideas that we had started talking about last year was how could we leverage generative AI to be able to assist program managers with the matching process. And so that's where the lovely Candice and Donato came on board to help us build this tool, which has been very exciting.
Interesting. I'm gonna ask something to Candice, but like before that, let me post it. Like, let's see. I'm gonna check in the chat. We have Ibrahim, which is my colleague, who's gonna handle the chat. Any questions, he will be able to help answer, and he will share links that we talk about during the topic. So Ibrahim, looking after both on the Twitch side and also in the YouTube side. Please ask questions, whatever you might have, and say hello to Erie Edits, and then hi from Dallas, Texas. Okay, hi Amir. And Data Guy _123 is one of our regulars. It's raining in the UK. Yes, exactly. I've just told me and Tara just say that it's raining in the UK. Well, in Brazil, but the night is sunny and lovely. Watching from Los Angeles, weather report cloudy. Okay, I think it's maybe only Donato has good weather now. And then, hi, Magdalene, watching from Belgium, a bit cloudy. Hello from Nairobi, Kenya, and so on. Okay, let me post the chat, and I'm going to go back to the topic, and I'm going to ask Candice and specific on this AI technology. So, of course, like when we talk about AI technology and mentorship is really human-centric, I would say. But technology, I'm not saying it's not human, but like it's sometimes contradicts each other. So at some point when you implement like AI technology, you need to balance that the AI technology, but also need to manage that or maintaining the human element, which is important for this mentorship. So how this tool or the role of GenAI approach that?
Yeah, I think that's a great question. I also hit it daily in my day job as a specialist for the Q developer team. But what we've found is that it really is important to make sure that we keep the human in the loop, right? There are so many applicants and so many mentors who also want to be part of this program. And people were going through these lists by hand to identify the top candidates. And so that took a very, very long time. So we were thinking this is going to help make that process quite a bit more effective, more efficient. But at the same time, we want to make sure that the people still, we want to make sure that that person touch, that human touch is still part of the whole thing. So what we've kind of ended up doing, and you'll see a demo, like a little bit of an overview of how it works from Donato later, is that we kind of do a thing where we're summarizing the different abilities and what they want to get out of this mentorship program, and then we come up with a recommendation of matches, and then there's multiple matches both ways, and then we hand that over to the program managers to make that final call. So we have found that it's really important to not let the AI just do all of the work for us, but definitely keep the human in the loop as you go through that, just to kind of speed it up along the way.
Okay, just to summarize what you just explained before. So the AI tool will help on the beginning of the process to do all the heavy lifting of the matching, but the final decisions will have like human to do the judgment, like the program managers within that regions that will check like, okay, yes, this is the correct match because of certain criteria that we have, and so on. It's not the AI tool just give the result for this is the matching and that's it, right?
Absolutely. Yeah. We don't want to match someone. If someone wants to learn about security, they need to have someone who has some security in their background as their mentor. So that's kind of where the AI can come in so that a person doesn't have to read each of these submissions.
Okay. And talking about this, how we combine or maintain the balance for humans and then this AI technology is I want to kind of like dive a bit deeper. So it's going to the topic around like ethical AI, responsible AI. And of course, as you mentioned, you think about it in the design. So would you be able to explain like what role that responsible AI play in within the design within the tool?
Yeah, absolutely. So there are, I think, 8 core dimensions of responsible AI, and we try to address or at least consider each of those as you go through. And so there's one of the dimensions is controllability, and so we want to make sure that the output coming out kind of makes sense. We want to make sure that privacy and security is built in from the very beginning. At AWS, we believe that security is foundational, so that is critical to make sure that we have that in there. Safety, fairness, robustness, explainability, transparency, governance. I think those are all of the dimensions. We have a webpage that you can go to and check that out. So we just wanted to kind of go through and make sure that all of those are considered as we go through this, and we'll dive deeper into each of these. But as an example, we could talk about governance. And so within the governance, we have things called the model cards. That's going to be a little bit of the governance as well as explainability or transparency, kind of giving you a little indication of how this model is working. So that is a thing that AWS has, is these model cards. And then we also wanted to make this transparent from the very beginning. So whenever we decided to go this route, we had to let applicants know that our application does include some AI tools to help assist in the matching process. So just covering our bases from like the legal perspective and things like that. We want to be very transparent with the fact that we are using this, just so that people know as they're coming into the whole process. And then we can kind of talk a little bit more about the people-centered approach as well. I think that's something that we've tried to definitely integrate in through the whole entire thing as well.
Yeah. Any like Tara, you want to chime in like a
Yeah,
approach, like human-centered design?
Yeah, sure, absolutely. So as Candace said, obviously we have many different pillars of responsible AI, but one of the other ways that we really have thought about the way we've approached this solution, and similar to how AWS approaches AI as well, is around taking a people-centric approach. Because when you think about it, at the end of the day, people are in every part of AI, whether you intend to or not, from the development team all the way through to the users. There are going to be people involved at every step. And so we really wanted to make a conscious effort to focus on how are we catering for people at every step, but also how are we as a team approaching the problem. So for example, if we think about the development team that we brought together, we made a really conscious effort to bring together a very diverse team. You'll see ourselves as well as the rest of our team, and we bring different skill sets, different backgrounds, different languages, different locations, different cultures, so many different diverse elements. So for us to be able to really think about, are we approaching this tool from the right way? Is there anything that we've missed? And that way we can hopefully build something that's really well-rounded and we'll be able to really serve our community.
Okay. Thanks, Tara. Thanks, Candice. And then diving deeper, a bit even more deeper to this responsible AI topic, because it's quite a hot topic and everyone talk about it, how we actually implement it in practice. So do you have some example exactly related to this topic and related to the tool that we developed that you already considers within the core dimensions while designing this tool specifically? Either Donato, you might want to start
sure.
first.
Yeah, I can take that one. So specifically talking about, for example, explainability, which I think is paramount for this application.
Yeah.
We leave an audit trail for pretty much every decision that the system makes throughout. And we do that by eliciting some form of reasoning from the generative AI models, because this functions, and I'll have to dive deeper here technologically, So this functions as sort of a local explainability, because these reasoned answers, meaning when the generative AI model not only states its decision, but also the reasoning behind why, this gives us a window into its inference processing, right? It helps us understand why it generated that specific output, and it improves like the interpretability of the rationales that were leveraged, and most importantly, it helps us make sure that it's aligned with our original intentions. So these audit trails, they feed back into our development process as part of our prompt engineering efforts to align the system to the PMs and all the subject matter experts that we consult, like Tara mentioned, whilst developing this automation tool.
Okay. Any okay, I know the mention of responsible AI, there is like some others as well. Is anything else that you consider example of how you consider responsible AI dimension within this tool?
Yeah, we could talk a little bit too about fairness. So the fairness dimension is just around to make sure that the tool is behaving in a similar way across different groups of stakeholders. And so to do that, we just kind of removed it. So we removed personally identifiable information. We just take that part out so that that's not a consideration as we're starting to make those matches. So that way we don't have things like age or gender, although this program is for people who identify as female. But we take out age and race and things like that aren't super relevant to that actual matching. We do keep things in as far as like location, so that it's easy as far as time zones and things like that. Donato will show you some of that in a little bit. And then the match actually makes a score when it comes out. So it comes out with a score for us to track overall, but we don't actually give that score to the PMs. So we give them a list, but not like this person is 1, 2, 3, 4, 5, whatever best match. So that's another way that we try to keep that bias out of there. And then let's see, we're also considering responsible AI and this fairness piece within the prompt itself. So we're just trying to make sure that the prompt does not have like inherent bias as we're giving that to the model. So those are a few of the ways where we're trying the best we can to make sure that this is fair, doesn't have bias, but also at the same time, it's quite a balance, which is why it's important to keep the human in the loop. Make sure that they're going to have some kind of I hate to say the word synergy, it just is one of those that kind of bugs me, but make sure that people have some kind of commonality that they can really have a great relationship.
Okay, yeah, I 100% agree. And any other consideration, or is just those two considerations that you have?
Oh no, yeah, I can also speak of safety as one of those pillars for responsible AI. I mean, as with any technology, the deployers they need to implement like some appropriate form of mechanism to protect the data that is processed or handled from the system, that from like exfiltration or spoofing, any kind of threat. But generative AI systems, they introduce a new range of threats, right? So let's take prompt injection as an example. This is where an attacker might try and manipulate the prompt that is fed into the LLM, crafting the inputs maliciously, trying to cause the LLM to misbehave or to act on or ignore its rules, right? So for that, we do leverage some mechanisms that are provided by AWS in the form of Bedrock guardrails, for example, that will go a long way towards mitigating most of these threats related to jailbreaking or to prompt injection, right? But we also leverage models that were pre-trained with these concerns in mind as well. So they also add in a layer of protection, of safety, right, on the system. And we also leverage like traditional forms of defense in depth, like validating or sanitizing inputs as they come in to remove special characters, and rate limiting to avoid like issues with overuse or abuse and stuff like that. Right.
Okay. In the Bedrock guardrail, is it like out of the box tool that like the audience can use and doesn't have to like build this guardrail from scratch?
Sure. Yes. So guardrails are part of Bedrock. So just to bring everyone into the same page, Bedrock came to existence as this way to access third-party models or even Amazon models via an API, but it's grown a lot to become like this one-stop shop or platform to cater for additional needs. So for example, Bedrock knowledge bases will offer some form of managed RAG or retrieval augmented generation. And Bedrock guardrails does offer this layer of protection, both for sanitize or validating the inputs as well as outputs as well generated by the models. So yeah, that's like you mentioned, it's you can plug onto AWS experience, building these forms of mitigations and leverage on your systems as well.
Okay, thanks to that. So how about the dimension of like veracity and also like robustness?
Sure. We apply strict prompt engineering in these cases and I believe this is part of our alignment efforts as well. And for that, we did iterate a lot while developing, right, to make sure that the scoring was aligned to our intended baselines. One of these prompting techniques as well is to set a persona for the LLM to work as well. So we did also work on establishing what this program manager persona would be like, or program manager assistant persona would be like. Also recalling that the system is meant to assist or to co-pilot along with the PMs in arriving at the final recommendations, right?
Yeah. So I can like if I summarize this again, like it's working backwards from the user who is going to using it, what exactly we want to achieve, and like thinking about this like responsible AI in the beginning of from the design itself.
Yes, exactly. So part of our work was diving deep into how these PMs would evaluate or do the manual matchings, because remember the main challenge here is that of scale. That's the bottleneck now that we're reaching such high numbers. So we worked backwards from that process in order to build the system.
Yeah, so if like anyone in the audience wants to start like the generative AI project or just an AI project, it's good to start to understand like what exactly the problem you want to solve, and before thinking about what tool you want to use, what model algorithm you want to use, like how good looks like for the outcome that they want it to be, and then working backwards from that, while also thinking how to implement that responsibly from the beginning, from the design stage. Okay, let me just double check. Ibrahim share that she built LinkedIn group. Join for any announcement. It will be in she builds LinkedIn group. And then also, if anyone interested to know more about responsible AI within AWS, there is a webpage that you can go through as well. And then last minute comments. Okay. Hi, watching from Himalayas. Okay, hello. Habib Majun Yadav. Okay, I'm gonna like we're talking about a lot of like theoretical, like okay, what's responsible AI and how these mentorships married with the responsible AI, how we implement this tool, why we did this tool, all the backgrounds, all the driver to build these tools. Now let's go a little bit more technical and talk about like what is the end-to-end, what is the building blocks that that you use, or the components to actually build these tools.
Cool. I can also take on that. And I've prepared an architectural diagram, a simplified version of the architecture of the system, just to make it more clear about what we're talking. So the way the system works is for this first version, we don't really have a UI. So the user experience is basically part of the core team will be able to upload the applications containing the form responses, both from mentees and mentors, into an Amazon S3 bucket. So just reminding everyone, S3 is a service that offers object storage on AWS. We leverage another service called Event Bridge, on which we're able to establish event notifications to react to those files being uploaded to S3 and trigger some form of work. In this case, we trigger the execution of an AWS Step Functions workflow. So Step Functions is able to orchestrate many different actions integrating various AWS services. And in this case, it will implement our matching algorithm. On a higher level, it leverages serverless services such as Lambda, DynamoDB, S3 itself, and Bedrock, the star of the show here, to implement our matching algorithm. And I even prepared a video animation that can go a long way in explaining what this architecture that is shown here will do. So if you don't mind, Lydia, let me share this video and I'll explain as I go along. And
anyone in the chat, if you want to.
Oh yeah, I'll hold it. I'll hold my mic here and see if it's maybe rubbing against my shirt. Thanks for the feedback, data guy. Cool.
Anyone in the chat, if you want to ask questions, please do ask. And Donato will just go through how it works, demoing how exactly it works.
Cool. And by the way, this animation, it was built from code using an animation library called Manim, and I vibe coded it using Q. So I was able to really fast develop it. So the first step in the algorithm is taking in those applications and validating the inputs, because some inputs, like I'm illustrating here, mentee 2 or mentor 3, might be invalid. When we say invalid, is they can maybe have sent an empty application, or an application that is just a bunch of random characters. And so the first thing we'll do is try to remove these invalid ones before we go on to the next step. So those valid applications will proceed to the next step.
So essentially you're doing like data cleansing and so on, right?
Yeah. So this is where, for example, we'll check for those invalid characters, or maybe we'll check for really, really, really short answers. That's where people will simply say like one word, which is sort of an invalid application. We want to skim over those, right? So the next thing we do is, from those valid mentees and valid mentors, we'll build out all possible candidate pairs, right? So, and this is a contrived example here, but you can imagine that at the current scale that the program is running, this will yield several thousand, potentially hundreds of thousands of possible pairs, because this is a combinatorics problem, right? And it scales exponentially here. So in this example here, 12 pairs were formed. The next step that we do is to filter out now invalid pairs. So these invalid pairs are filtered out based on a deterministic criteria. What we mean by that is, let's say, for example, initially we don't want to pair a mentee candidate from Brazil with a mentor candidate from India, for example. There's a challenge of language, of distance, and everything, right?
Yep.
Another deterministic criteria that we will consider is maybe even within a same region, there might be big time zone differences that we've seen in past experiences that also pose a challenge when running through those 12-week program, right? So this is the first thing that we'll do when filtering out those invalid pairs. So in this example here, 9 valid pairs will proceed to the next step. And now it starts to get more interesting. On step 4, we will perform a filtering by similarity. And in this case here, we start using generative AI to calculate those similarities. And the way we do that is we have crafted a specific prompt that places together aspects or a summarized version of the mentee's application along with a summarized version of the mentor's application, but the summarization process elicits some of the things that we want to capture in terms of similarity, like say, for example, the mentee's aspirations with the mentor's past experience or current experience, right? And then we calculate what we call a cosine similarity. This is a measure of how similar those two applications are, right? The application from the mentee and the mentor, right? Then the pairs with lower similarity scores, they are dropped. And I'll make a light explanation here is that one of the reasons why we do this filtering by similarity at this stage is because the scale of the system is just so huge that if we were to pass all valid pairs to the next step, it would take ages to run the next validation step, which is actually obtaining the score for the pair. And this is where we're going to leverage powerful LLMs, making multiple calls to evaluate the match quality across many different dimensions. So let's take, for example, this candidate pair M1, mentor 1, mentee 1. We will evaluate different dimensions. Each dimension will have a score given by the LLM, and remember, aligned by our process of like working backwards with the PMs, that will arrive at a resulting score. We do that for every pair that pass the similarity filtering, right? Cool. So at the end of this process, we have. Let me just go back one minute. We will have the score for every possible pair. Now, yeah, go ahead, Lydia.
No, sorry, carry on.
Sure. So at this moment, we could, for example, just apply a naive selection algorithm and say, oh, for every mentor, I'll pick the top scoring pairs. But this naive approach might yield some like bad results overall. It could lead to, for example, because of the fact that our mentors and our, let's say, a scarce resource, right? In this program, they will mentor a single mentee. What could happen is we take a very, very good match here, let's say the 91%, but then all that is left for the others are lower scoring matches. So we can't just simply do this naive approach towards generating the final recommendations. So in the end, we also have an optimization process. So think of this screen here as all the possible, scored matches that came out of our LLM system, right? So in this simulated example here, with just 5 mentors and 15 mentees, there's a total of 40 possible pairs. But again, thinking scale in our actual system, this can come up to thousands, right? It's, again, humanly impossible for a PM to go over all these pairs to make the final evaluation. So what we will do is execute an optimization algorithm that will pass some restrictions, let's say how many mentees per mentor we want to give the PM. So how many mentors per mentee we want to feed back to the PM so they do their human evaluation. And this will come out with a list that optimizes for the total network score or the average score for the pairs. And this goes one step beyond that naive approach, right? And will optimize for making, as a whole, everyone happy, right?
Yeah.
So this is how this system works in a nutshell. I know it's a slightly big nutshell, but it's as best as I can explain it here.
So there's some question in the chat, but just trying to clarify. So the first step is you're gonna cleanse the data because garbage in, garbage out. So cleanse the data. Then you start the pair, check the criteria, the basic criteria to match what is similarity, and then you start pairing all the possible pair, and then you filter out the pairing which top the best possible pair for the mentor and mentee matches. If I oversimplify it, that's the process that you follow.
Yeah, in a nutshell, that's the process. And again, one of the challenges that we're trying to address here is that going through that hard criteria wasn't that much of a challenge before to our PMs. It's what happened right after, right? So they were generally given maybe dozens or hundreds of mentors and potentially thousands of mentees, and had this extremely hard work of coming up with the pairings manually.
Right. And the Bedrock piece coming for the summarization part, summarizing what each of the applicant, either mentor and mentees, what their goals or criteria when they apply for this program.
Cool. For that, let me switch back to the architecture diagram, and it will make it a little bit more clear where we leverage Bedrock. Cool. So the first time we leverage Bedrock is when we're scoring the similarity. For that, we use a specific form of generative AI model because
Sorry, Donato, you might to hold your mic again because.
Yeah, cool. So we go the first moment we leverage Bedrock is when we're scoring the similarity between the valid pairs, and at this moment we use a specific form of generative AI model called embeddings model. So this is a form of model that instead of generating text or generating an image or generating audio like Sonic and Novosonic models now do, it will generate a large dimension vector. And the intuition is that this vectors that represent similar texts are close to each other. That's why we use that metric of cosine similarity. The cosine similarity will measure how close these vectors live in this higher dimensional embedding space. So this is the first time we use Bedrock. The second time we use Bedrock is for diving deep to score the pairs. We will invoke Bedrock multiple times across many dimensions. As an example of a dimension, it could be, for example, again, how the goals of the mentee might align with the abilities of a mentor, right? And intuitively, what we want is the LLM to score higher those pairs where the mentor has a great capacity to influence or to help the mentee with her aspirations, right? And score slightly lower those pairs where maybe the mentor's capabilities do not align very well with the mentee's goals. And now, at this moment, we're invoking models that do output text, not only embeddings. And one of the parts of the output, like we mentioned before when talking about responsible AI, is precisely the reasoning why the LLM thinks or considers this pair a high or a low score in terms of this dimension, right? So when I showed in the animation just a percentage value, As a matter of fact, what it outputs is the percentage value and that auditing track of why it gave that score,
Okay.
right? And this will help the PMs not only validate that it makes sense that a certain candidate, a certain pair was suggested, right? But also now during our build phase is helping us align that with the knowledge of the PMs.
Okay, thank you. I have another question, but let me check in the chat. There's hi from Singapore from Seeker. Hello, and then Data Go. Thank you. And responding to Q, your vibe coding Q is some personal assistant. And then Ibrahim, if anyone doesn't know Amazon Q, there is a link from Ibrahim. Check that out. Really great. And from the Seeker from Singapore, asking what is the benefit? Why we choose of even bridge over SKS or SQS?
Oh, cool. That's an interesting question. So the idea here is that we just want to react to a file having been uploaded to S3, right? We're not talking about maybe say multiple events where perhaps using SQS, or I think maybe Seeker meant SNS in this case, would have made more sense, right? Um, one place that maybe SQS would have would fit in the system is maybe to decouple parts of the internal application there to make it like more scalable or something like that. But to that extent, we leverage a feature from step functions itself called distributed maps. So every time we see here this for each pair, what we're effectively doing is parallelizing, or to some concurrent extent, right, work across those different pairs. So let's say that step functions didn't have this feature of parallelizing using distributed maps. What we could do is the output of form pairs could have output a pair as a message, and we'd store all those pairs as messages on SQS, and then slowly consume those messages, calculating the score of similarity. And the same thing again after we apply the filters on those similar pairs. We could have output them to an SQS queue, and then slowly consume those messages and perform the deeper scoring for each pair, right?
Okay, makes sense. So it is possible to use SQS in this instance, but we choose even bridge for the reason that you just shared, right, Donato?
Yeah, well, I mean, again, event bridge at the beginning is just to inform us that a file was uploaded, and since that we don't expect that to happen a lot, maybe it could happen once for every region, or or maybe even just once with all the applications, right? We don't really need something like SQS or SNS.
Yeah. Let me see in the chat. Tara has smiling face. Yes, she is always smiling. And then there's a comment chat. Could you turn this into a product you could provide to AWS enterprise customers, which enables them to facilitate their own mentorship program? Anyone who is interested, +1 on this chat, and then we never know, right? This is a pilot, and then if it's benefit to more community, why not? If you +1, we have data point to bring up to the next stage.
Yeah, I mean, well, we always work backwards from those demands coming from customers, right? It wouldn't be a first time that maybe like just a sheer suggestion on a chat became an AWS service, as many of the services and features do come from this feedback from actual customers.
Thank you, Donato. Just to clarify, so the actual process in the past, in previous year, usually like all the program managers will get the applications and manually look into the application, eyeballing the application, make sure it's a match, takes days. Now, the idea is those applications gonna go to that S3, Amazon S3 bucket in the top left corner, and it will kick off the GenAI tool and provide, at the end, it will provide the recommendations that the program managers can dive deeper, like why is being the match, and then if it's actually makes sense to be a match, then they can approve it. They can still challenge it to say like, no, it's completely not a match. We want to double check the main source of applications. Am I understanding correct?
Yeah, that's 100% correct. So again, this is a tool to help PMs do their work, not to completely replace. So the output is this focused list of recommended pairs, but they still have access to the applications to, like you mentioned, challenge or fine-tune some of the recommendations.
Okay, so sounds like a great tool, but like how we can, for example, like measure the success for the tool, like how we know, like, okay, once we have this tool, when it's being used, that is a success, or we can decide like, okay, there is things need to improve. Like what actually the points that we measure. Any of you have idea? Maybe Candice?
So I think as far as you're asking about, like, how do we measure how this is going to work? Okay, so we are figuring that out. This is our very first year to use this tool. And so what we're hoping to do is kind of run the tool alongside like a control group, essentially. So we will run the tool, and then we'll also have the PMs do their normal thing, and then we can see how well those matches kind of line up. So that's what we're going to try this year, a hybrid approach, and then we can kind of fine tune and see how things go, if we need to make any adjustments and things like that. Maybe we need to provide a larger number of candidates to the PM. Maybe we need to loosen up or tighten up different requirements. But that's kind of our plan, is to have the tool run alongside the humans and kind of compare those as they come out.
Okay, and then I'm pretty sure like all this development that we're doing, there is always like, it's not going to be like sunshine and rainbow, but will be like some challenges or things that you don't expect and happen. It's not supposed to happen, but it's happened, and things that you just found out like when you build it. Any things that will worth to share for just for lesson learned for anyone's one trying to develop this type of project? Maybe either Tara or Donato.
Happy to take that. So a couple of things. One, it already was alluded to, but we made a very conscious decision about what role GenAI was going to play in this tool. And so my first recommendation is that decision influences everything, the design, the build, how the users interact with it, all of that. So really starting with that and thinking about what role you want it to play, and then designing a system from there. Second, one of the challenges that we had was actually taking all of the experience and intuition that our PMs go through and actually translating that into effectively code, and something that GenAI could help with. And that turned out to be a much bigger challenge than we expected, both in terms of trying to translate intuition into something tangible, but also it highlighted an opportunity for us internally to streamline some of our operations, because we run this program globally, and it turned out through this process that different regions had slight tweaks on the way that they approached it. So it really enabled us to actually, in the process of translating that, identify any regional peculiarities, and then be able to translate that into the tool. And then probably I would also say one of the most valuable parts of building this has been the team. At the end of the day, this is something that we do side of desks. This isn't our full-time jobs. And so finding people who are really passionate about the cause and the mission, and also passionate about building something with GenAI. It's really been a dream to work with everyone, and yourself as well, Lydia, you've been involved too. So definitely finding the right team as well to build these kinds of tools.
Anything else, either Donato or Candice, you want to add more on the challenges that when building these tools?
Sure. Yeah, I think one of the main challenges is precisely like testing, right? And for that, we went a little bit meta here. So we generated like synthetic data. What I mean by synthetic data is I prompted a model to answer the application form more than a few times. And then we use this data to test the system itself. And one of the advantages of that is that when I'm generating the data, I'm sorry again for the mic. When I'm generating the data, we can go like skip a step and ask for, say, a good match, and then fill out the application, or examples of bad matches and then fill out the application, because then we can run that through the system and validate that its understanding was correct as well, right? And so that was an interesting challenge to tackle when developing the system.
Okay, thank you. And I think it's related to the question before, whether we're going to develop this something new. But like, what is the plan to evolve on this tool in the future? Any new features or capabilities that you are considering, or even like turn it to be like one of AWS services? Maybe, never know.
Sure. I think first and foremost, we'll be incorporating whatever lesson we learn now that we run the system in this hybrid mode that Tara mentioned, right? That when we run it alongside with the PMs, because that information will be invaluable for us to improve the system, right? Another aspect that we might want to incorporate for future versions is some UI. As you saw in the architecture now, the system is a bit rough on end users. It requires some interacting with the AWS console. So that might also be a dimension we incorporate for future versions, a UI, a proper UI for using the system. And last but not least, what we've been seeing this field of generative AI is constant evolution, right? And one of the benefits of using AWS is being able to tap into that constant evolution in very fast, right? And iterate fast on using what's state of the art in terms of technology. And the new I won't say hype, because it seems very promising, is incorporating some agenticness into the system. So that might be also something to explore for future versions, incorporating agency into the system as opposed to this more rigid workflow that I presented to everyone.
Thank you. And then let's say, like, I think somebody already asked a question, right? Like, if they have like a mentorship program within the organization or running mentorship program independently, it's probably for Tara, as you are co-founder of the She Built mentorship program. What advice that you will give to the audience if they are start considering, like, yes, we're going to have an AI tools to support their own mentorship program?
Sure. So one of the tips I would give is to start small but think big. And when we were designing this, we had so many different ideas about, taking on the whole world pretty much with this. But really, at the end of the day, we wanted to build something in quite a short amount of time that we could actually use and pilot for this year. And as Donato and Candice have said, actually run with it this year, get all of the feedback from the PMs, and then continue to iterate on it until it's actually used. It's hard to kind of identify exactly how it's going to play out. So definitely starting small and then continuing to iterate on it would be my number one tip.
Thank you very much, Sarah. Let me just check in the chat quickly. Hello, Prasad is one of the hosts in the show. Crazy DB5 is one of our regular. Great insights. Thanks for sharing. You're welcome. There's one last question. Can we build this reference architecture in free tier? So is all the services that we use have the free tier offering?
I believe I can take that one. Unfortunately, not. Bedrock itself does not offer a free tier, so you would have to pay for the invocations of the models, both the embeddings models and the completion models, those that generate the text, right, and perform the scoring. So this architecture is not completely free tierable.
Okay, there is some other component is free, has a free tier option. Is just the the main engine within this tool, which is Bedrock, which currently we don't have the free tier options.
Yes, but I mean the entire architecture is composed of serverless services. So to one point, you would pay for use, right? Lambda does come with a very generous free tier. It's really hard to exhaust the free tier for Lambda. Aside from that, maybe Event Bridge itself also comes without cost for generating those events, but everything else might not fall into a free tier. Yeah, that's something interesting that we might evaluate in our path to maybe making this a service or publishing it as a reference architecture on AWS side itself. Thanks for the feedback there.
Thank you, Donato. So my last one question is probably I'm going to address it to Sarah. As we know, we open the applications. Like how, if anyone interested to be in AWS Shipbuild Mentorship program this year, how they can like register or apply.
Thanks, Lydia. So yeah, super exciting. We opened our applications at the start of last week, and they'll be open for the whole month of June. So closing 11:59, June 30 PT time. So I believe Ibrahim has dropped the application link for mentees in the chat. So if you are interested in joining the program and you're either starting out in your tech career or you're looking to grow your tech career, we'd really love to hear from you.
Thank you very much. Yes, Ibrahim, drop a link in the chat. Also, apart from that, you should subscribe to AWS She Builds Tech Skills YouTube channel. Well, Candice will be the host in there. It's good for learning new skill for like in tech for women. And then I think that's all. I will wrap up. Thank you very much for watching. Don't forget, same time next week, 4 to 5 p.m. British summer time. Next week topic will be with Ibrahim actually about overview on data foundation for generative AI. So still GenAI, but more into like the how you build the strong foundation to build your GenAI application. Thank you very much, Tara. Thank you very much, Candice. Thank you very much, Donato. Thank you very much, the audience. See you again next week.
Thanks for having us.